This is a demo on Centripetal Force. First, you're gonna take a penny and squeeze it through a balloon. Make sure it goes all the way down to the bottom. Then you're gonna blow up the balloon. Balloon at the top, like you'd hold a bowling ball, and start swirling it in a circular motion, and you get the penny, so it you can see the penny moving. Once the coin begins spinning, you can use your other hand to stabilize the balloon, and the penny should keep going for about 30 seconds.
You have to look at the forces that are acting on the penny. The shape of the balloon makes the penny move in a circular path, otherwise the penny would want to move in a straight line. There is very little friction between the penny and the balloon. The main force that is acting here is centripetal force. The force is directed toward the center of the circle. It keeps the penny moving in the circular motion inside of the balloon.
This next demonstration also has to do with centripetal force. We have Clara who's going to help us. We have a board with our string coming out of 4 corners and our 2 cups filled with water. She's going to slowly start swinging it. And then when she's ready, she's going to go up and over her head. As you can see, the water is still in the cups and Clara is dry.
The board wants to remain in motion unless it's acted upon by an external force, Newton's first law. Newton's law requires the cup and board to continue moving in a circular path. The centripetal force keeps the force in the center and allows the cups to go in the circular motion without spilling the water.
These are cans, alligator clips, tin foil, tape, and whatever this is attached to the string, a pop tab with a pencil. Next, you put your safety goggles on. You have the TV plugged in. Then you simply just turn on the TV. Then you take it, go like that, starts rattling back and forth. Once I pick it up, it starts moving like that. The way that this works, the foil is a conductor, being a simple capacitor, and this is high voltage. The high voltage goes into this Coke bottle, this one being grounded. The electrons get repelled into this tab, pushing it into here. So this one builds up electrons, going back into the positives, but picking up electrons going back into here. And since the same repel and opposites attract, it pushes it back and forth through an endless cycle. Going back and forth, repelling the electrons and getting the positives.
First, you take your piece of PVC and cut it to the length that you want your potato launcher to be. Take your wooden dowel and attach a piece of duct tape. You want to attach the duct tape to the rod where it meets the PVC in length. The duct tape is used so when you slide the rod into the PVC, the rod can't go any farther. The next step in the potato launcher, you're going to need to take a potato, and you'll have a piece of potato in one end. With your wooden rod, you're going to take it and take the piece of potato and push it to the other end. When you get a piece of potato in the opposite end of the pole, you're going to need to get another piece at the other end. Pushing the rod in, you are decreasing the volume inside of the PVC but increasing the pressure. That is known as Boyle's law. And when I push the wooden rod in, the other piece of potato will be forced out and will go flying.
Hello! We're going to show you how to unlock your car from a farther distance. Your keys have a radio transmitter in it, making it unlock from a farther distance through radio waves, as far as you can get it. But how far can it go? Who knows? So let's see how far we can get.
1, 2, 3, 4, 5, 6, 7, 8. That's pretty far. I think if I had that much distance on it, that's a bad card. Still going.
Stop working. So I'm gonna move 2 steps back just to show you that I have more distance. As you can see, I'm very far away from my car. I have water. And with that, it amplifies it. Without the water, I can't unlock it from here. The electric field causes the positives to go up, the hydrogens, and the negatives to go down, the oxygens, to move in a motion like this because of the electric oscillating field, and it comes coherent with the radio signal to this bad boy right here.